Okay, so good evening, everyone. Welcome to the problem solving session for NPTEL online course on wastewater treatment and recycling. We are in week 11 right now, and I am Akash Saha, one of your teaching assistant for this course, and I am a PMRF scholar at the Department of Civil Engineering at IIT Madras, pursuing my PhD in environmental engineering. So this was the overview for this week's lecture. We started with concept of wastewater reuse and recycling. We saw the issues regarding the wastewater disposal and the need and the driving factors for its reuse and recycling. And we saw then different types of wastewater reuse and recycling. What are the different types of direct and indirect recycling, the different opportunities, and what are the different sectors for wastewater reuse, like in agriculture or aquaculture, then municipal, industrial, and environmental sectors. And then we saw the various potential of wastewater recycling, starting from the different reuse categories, the stages of the recycling, and the considerations that have to be taken for reuse for the direct and the indirect portable reuse. And then we saw the regulatory guidelines of WHO, US EPA, what are the operational considerations and various categories guidelines. And at last, we saw the difference between centralized and decentralized recycling, where we saw the various aspects of technical, social, financial, and institutional, and the various advantages and disadvantages of both the recycling types. So this was the whole overview of this week's lecture. So this week it was all theoretical. So I just have many multiple choice questions for you. I don't have any numericals right now. So we will see the multiple choice questions and discuss as required. Okay. So this is the first question. It says, which of the following is the most favorable option for sustainable wastewater management? So we have reclaim, reuse, reduce, and recycle. So you have to tell me which is the most favorable option for wastewater management.
Reduce.
Reduce, just a minute.
Yeah, it is C, reduce.
Yeah. So reduce, I think it is the correct answer, because if we see if we see the hierarchy of any waste management, so at first it comes reduce, because we have to focus more on the reduce, because if we reduce the generation of the wastewater itself, then the our management will be easier. And whereas reuse will come, like when we want to use it again, once the wastewater is generated, how we can reuse it again without with or without treatment. And at last we can also do recycling, which is in the third place. So reduce is the most favorable option for any wastewater management. Not only wastewater, if you see any type of waste, starting from solid waste, liquid waste, organic waste, any type of waste, we generally go for reduction, or we can also say it as source reduction, because if we generate lesser waste, it will be much easier to manage it rather than reusing or recycling. As we say that prevention is better than cure. So the same philosophy happens here. Okay. So the next question says reclaimed. So we have two statements. We have to find out which of them are incorrect. So the first statement says reclaimed water treated to secondary standards is suitable to be used in drip irrigation. And the second says, because reclaimed water quality is directly linked to crops that may be produced with that water, there may be additional regulatory controls that dictate when irrigation is applied and who is allowed on the property being irrigated. So we have two statements. It says about the use of the reclaimed water. So we have to say which of the statement is correct. Please go through the statements again. So the first statement says the use of reclaimed water in drip irrigation, and the second says that if we use reclaimed water, which can be directly linked to the crops, some additional regulatory controls may be required for the irrigation. So what do you think? Which of the option is correct?
This second option is correct.
Second option. So you are saying that statement 1 is correct and statement 2 is wrong.
No, statement 2 is correct and statement 1 is wrong.
Okay, so that means option C, right? Statement 1 is incorrect and statement 2 is correct. Anyone else who thinks the answer is the same? So Abdul says it as option C. So Abdul, can you tell me why do you think that the first statement is incorrect? Why it is incorrect?
Because the sprinkler system, if it is secondary treatment, that water directly going to the sprinkler system, it will damage this, some clogging or something will affect. That means it's properly,
Exactly.
it won't work. That sprinkler
Exactly.
system, it won't work.
Exactly. So whatever Abdul says is the correct answer. So C is the correct. We will see the explanation. So if we see that the compatibility of any agricultural operation, like for say drip irrigation, if we use the secondary treated water, because we know that in secondary treated water, most of the dissolved organics will be removed, some suspended organics will be removed, but many suspended organics will still be there, which are much smaller in size. So when we use them in the drip irrigation system, there are high chances that it will clog our system. So we should not definitely use this secondary treated wastewater in drip irrigation. We should only go for much higher removal, maybe tertiary treatment. And because in drip irrigation, the pores are very fine. And also, the second statement is true because it says that like more regulatory controls are required because there is a direct contact of the reclaimed water with the crops, because whatever reclaimed water we are using, that will be up will be uptaken by the crops for their growth. So there is a direct contact, and hence we need more regulatory controls before using it for any irrigation systems. So statement 1 was incorrect, whereas statement 2 is correct. Okay, so I hope others are fine with the explanation of these questions. If you have any doubt at any point of time, you can stop me and we can discuss it further. Okay, so we will move to the next question. So it says, which of the following is not an advantage of decentralized wastewater system? So we are comparing decentralized and centralized wastewater system. So which of them is not an advantage? So A is lesser treatment unit required. B is lesser cost of sewage transportation. C is more suitable for wastewater recycling. D is treatment can be applied on different scales. So which is not an advantage of decentralized wastewater system?
This auction treatment can be applied to different scales.
So why do you think it's a disadvantage?
Disadvantage means because decentralized is more advantage than centralized. Centralized, if it is, it will be
Yeah, yeah.
it is very expensive for centralized. If it is decentralized, some certain area that wastewater can be treated with the small units, and the same can be recycled there itself. That means the cost wise it will
No,
be
no.
economic.
Whatever you said is correct. But here it is saying that in
Which
decentralized system, we can apply various scales of treatment. I think you didn't understand the problem.
which of the following is not an advantage of decentralized? Yeah, that means disadvantage for the decentralized. That is
Ha,
the mean the question, isn't it?
whatever can be a disadvantage. Okay, you just
Okay.
mute your microphone for some second. I will explain this. So what do you mean by treatment can be applied on different scales? So it means that suppose uh, we have some decentralized wastewater treatment system where the where we have two types of decentralized wastewater system, where one they are using it for irrigation and one they are using for direct potable use. Okay, like potable users, they are using it for drinking purpose. So when we are using it for irrigation, the extent of treatment required will be lesser than the portable reuse, right? So based on our decentralized system and the recycling and the type of reuse, we can apply different scales of treatment. Whereas in a centralized treatment, the treatment scale will be same throughout the city. So for the whole city, we have the same scale of treatment. We will have the same scale of treatment. Whereas the advantage of decentralized system is if we have two different decentralized systems, we can go for different scales of treatment based on our reuse. Did you understand this?
Yes, sir. Then it is correct. Yeah, it is correct. Lesser treatment units required. That is the disadvantage.
So, so, so in the case of decentralized treatment system, so we may have to make more and more treatment units. Okay, so more and more treatment units will be required. So that is a disadvantage of decentralized wastewater management. So A is the correct option for this question. We will discuss all the advantages and disadvantages of C. So if we see the decentralized wastewater treatment, so what are the advantages? So first is it does not require large investment. Though the number of treatment units may be more, but it doesn't require very large units. So it doesn't require very large investment. And also it is easier to achieve high removal rates because since the units are not very large, so it is easier to control the operating parameters, and then thus we can get very high removal rates. Also low energy and maintenance is required. Also there is a less hydrological impact because there are no sewer networks or there is no need of transportation. And also it is preferable for local scale recycling. So as I discussed, based on our different types of recycling, the scale of treatment can be changed. Also, it is a green and sustainable solution, and it can be integrated in a flexible wastewater system. So, you might have heard about modular systems. So, if modular system is we can attach more and more units as and when required. So it is flexible. It can be integrated. And what are the disadvantage? The disadvantage is for some units the efficiency will may not be much better because since only suppose I am getting very low organic waste or very high organic waste and my treatment unit is designed for a different purpose, then the treatment efficiency for those kind of systems may not be so high. Okay. And also if you see there is a risk of public health issues because the humans like the society will be in direct contact with the decentralized system, so there may be higher risk of public health issues. And sometimes the operations and maintenance can be a burden for the owner because it has to be managed within the society, so it can be a burden to the owner. And it is hard to document the treatment effectiveness, and also there are risk of some failure if the O&M is not done properly. There may be some risk of failure of some of the units. So these are all the advantages and disadvantages of the decentralized wastewater system. Okay, so we will go to the next question. So it says that fill up the blanks concerning the correct flow of large wastewater recycling system. So it is given as collection, sewage transport, treatment, dash designated use. So what is the correct option here? Others also please try to answer, or you can write it in the chat box, whatever.
Reclaimed water transport.
Reclaimed water transport. So it was pretty simple because after the treatment we have to transport. So if we see, so first we will do the collection, that is the source of the wastewater generation, then transport, it will be through the sewerage systems, Then we will go for the water treatment. So water treatment can be of primary, preliminary, secondary, and advanced wastewater treatments. And then after the water treatment, we will transport the uh, reclaimed wastewater to the point of use. Okay, and at last it is designated reuse, like where we will be reusing the reclaimed wastewater for our application, for various applications. So this was the flow chart. Okay, we will go to the next question. It was a pretty simple question. The fifth question says the use of reclaimed water to create, enhance, sustain, and augment natural water bodies is an example of. Okay, is an example of environmental reuse, industrial reuse, direct potable reuse, none of the above.
Environmental reuse.
Environmental reuse. Okay, so it is saying that for the reclaimed water, if we are using it to create, enhance, or sustain or augment any natural body, that is any environmental system that is directly given. So it is an example of environmental use, because there are various types of reuse available. So this is an example of environmental reuse. So we can see the various type of category of reuse, starting from urban reuse, agriculture reuse, impoundments, environmental reuse, industrial reuse, groundwater recharge or non-potable reuse, and then potable reuse, in which we have IPR, which is the indirect potable use, and the DPR, direct potable use. So for different types of reuse, we have the various descriptions given. So these are all the various types of reuse of wastewater after reclamation. So this has been taken from the US EPA guidelines for water reuse. So we have US EPA guidelines, WHO guidelines, various national and other international guidelines. So you can see and you can make a judgment, because based on the different types of reuse required for various purposes. So for each type of reuse, there will be a set of instructions or a set of what to say, discharge, effluent discharge standards will be given. So based on the reuse criteria, we have to do the treatment to achieve the effluent discharge standards. Okay, so we will see the next question. Okay, the next question says identify the most appropriate option for assertion statement and reasoning statement. So first statement says treating and recycling grey water is easier than sewage treatment and recycling. Second, grey water contains lesser pathogens, ammonia, and organic load than sewage. So which of the option?
Both are correct.
Both are
And
correct.
explanation is also right.
Explanation is also right. Anybody else thinks if
Both A and R is true, and R is the correct.
okay, so I think it's a unanimous answer because both are correct. Both A and R are correct, and R is the correct explanation of A. So option A is correct. So if we see for grey water recycling, so do you remember what are the different components of grey water? Can somebody tell me what are the components of grey water? You can see in the picture itself. Just let me know what are the different component of the grey water. You are not able to recall. So grey water contains everything except the washroom thing. Okay, so whatever from the kitchen waste or the dishwashing waste, whatever we are getting, which has a very less organic waste as compared to the commode or whatever. So uh, everything comes in gray water, whereas in the case of municipal sewage water, there is a higher degree of treatment is required because it has more organic matter and pathogenic contamination. Okay, whereas in the case of gray water, it has low organic waste and low pathogens, and also very little ammonia nitrogen. Okay, we will move to the next question. So it's very simple question. Which of the following resources cannot be recovered from wastewater? Water, minerals, food, energy.
Food.
Food. Okay. So can anyone give me an example of the types of minerals that can be recovered from wastewater? You know that minerals can be recovered. Food is not the right answer. So can someone tell me any mineral that can be recovered from gray water or sorry, wastewater?
In RO system, minerals are extracted from the water.
Exactly. Can you give one example? What kind of minerals are extracted or anything? Just think over it if you don't know the answer. Okay. So though it looks very simple, but just think over it. What are the different minerals? So of course, food is the right answer for this question. Okay. Okay, we'll move to the next question. A safe option to reuse municipal wastewater subjected to limited treatment is irrigation of non-food crops, irrigation of landscape and recreational areas, non-contact domestic use, all of the above. So what is a safe option to reuse the municipal wastewater subjected to limited treatment?
All.
All of the above, sir.
All of the above. Okay, so that is the right answer because all of the above. We can see the list of all the different reuse like in irrigation for landscaping or agriculture or aquaculture. Then we have various non-contact domestic applications, some contact domestic applications, industrial application, recreational, or the discharge to surface water or groundwater discharge. So these are all the different reuse with different uh, efficiencies of treatment. Okay, so based on our requirement, we can treat the wastewater and reuse it. Okay, so the next question. The concept of zero liquid discharge entails effluent produced within the industry be treated and recycled for industrial usage, complete and tertiary treatment of industrial water for potable reuse, direct potable reuse, industrial processes to be upgraded so that water usage is drastically reduced, treated effluent to be used for stream flow augmentation rather than river disposal. So which of the definition is correct for zero liquid discharge? So what do you mean by zero liquid discharge? Very simple. It's given in the statement itself.
Yeah. If it is an industrial area, within the compound, all the wastage water to be treated there itself and totally used there itself without disposing
Exactly.
anything beyond the compound from the
E-
industrial area.
exactly. So what will be the right answer?
The effluent produced within the industry to be
Exactly.
treated and recycled
Yes.
for industrial use. There itself it is using.
Yes, exactly. So whatever water or wastewater that is generated within the premises of the industry, it has to be completely recovered. None of the wastewater can be disposed of or thrown from the compound of the industry. It has to be totally treated and reused within the system. Okay, so this is what zero liquid discharge means. So A is the correct answer. So we can see a small example where from the industry you can see like how first it is going for a physicochemical pre-treatment where the various materials like the sand, oil or the grit materials will be removed. Then it will go for a biological treatment where most of the microorganisms will work to remove the organic waste, or we can say the various dissolved organics present generally, and then it is going for the membrane filtration. So what membrane filtration will do, it's a tertiary treatment, so it will remove most of the suspended contaminants, and many of the dissolved contaminants also it can remove, like if we have the various RO or the nanofiltration techniques, and it will also remove the pathogens, that is the bacteria or any other microorganisms that are present. So again these are removed, and at last for complete recovery of the water we will do the evapor concentration. So the further it will concentrate all the contaminants that is present, and also the salts can be recovered from the system, and all the water can again be recycled back into the industry. So there is an industry like Veolia Water Technologies. So they have given this schematic for zero liquid discharge. So there are various steps like I have shown it. They have used membrane filtration and evapor concentration. So different types of techniques can be used for the zero liquid discharge. And on the left hand side, I have given some of the advantages of the zero liquid discharge. So it is in trend nowadays, so each industry has to follow, because if you see various textile industries and other industries or leather processing industries, a lot of wastewater is being generated, and that too they are just discharging into the wastewater in the natural bodies. So now many of the governments are making strict rules that they have to treat it and reuse it in the same premises. So it is very important nowadays to know about the zero liquid discharge concept. So it is not necessary that all the industries will use the same type of treatment. So based on their BOD, COD, their biodegradability, and their types of or PPCBs that they are generating, we have to go for various treatments, and we have to recover all the water that can be used within the premises. Maybe they may be using it for agriculture, landscaping in the system, or they are refining it to so much to such an extent that they can use it also use for potable as a potable water. So it depends based on the treatment technology or the reuse capability. Okay, so this was all about zero liquid discharge. Now, next question. The approximate potential for reclaiming water from a typical municipal wastewater system is 95 to 100%, 70 to 90%, 40 to 60%, 20 to 40%.
That answer is B, 70 to 90%.
So it's a pretty simple question, 70 to 90%, because we know that uh, the out of the total water demand that we get in our household, 80 to 90% will come out as wastewater. And if we consider some further 10% losses, which during the transportation through the sewage network or the collection, we can assume that 70 to 90 or 70 to 80% can be reclaimed for our reuse or recycling. Okay. next question says identify the correct statement. So first statement says industrial wastewater can be reused for construction activities with minimal treatment. The least preferred use of recycled sewage is landscape irrigation and fire protection. Recycled sewage will require the highest degree of treatment for direct potable use. So which of the statements are correct?
statement 1 and 3 are correct.
Yeah. So I think it's the right answer because why do you think that statement 2 is incorrect?
Because sir, uh,
It is not the least preferred use. Okay, so
it
it
is the
is huh,
most preferred.
one of the one of the most present and the least preferred use is the direct potable use. Okay, so least preferred is the direct potable use because people are still not okay with reusing the wastewater directly as a drinking water thing. So still some social implications are attached with wastewater reuse and people are not okay. It's a social concern. It's not a technological or financial concern. It's a social issue. So we have to get over it because now there are various treatment technologies available which can make sure that the wastewater is safe for drinking itself. Okay. So, what do you think? Like, if we talking about the first statement, industrial wastewater can be used for construction activities with minimal treatment. So, what do you think? Like, if we are using the wastewater for making or mixing concrete, what will happen to the concrete? They are saying that with minimal treatment, but uh, will it be good? Should we go for secondary treated or should we go for tertiary treated? Because we know that no right a lot of water is required for mixing concrete or for setting of concrete. A lot of water is required and generally people use potable water for mixing and setting of concrete. So if we can use the industrial wastewater or maybe municipal wastewater also with limited treatment, do you think is there any problem with the concrete?
Yeah, it is. There is problem for the concrete because some chemicals it is a disadvantage for the concrete mixing.
No, so can you
So
tell me what exact property will be affected of concrete?
that is chemical deterioration. It will form deterioration, I
Okay,
think.
you are going in the right track, but I was just wanted to know the exact. So basically, there is a lot of organic matter present in the wastewater, right? So it
Yeah.
will definitely reduce the compressive strength because we know inorganic materials are being used to make concrete. So if you are putting organic things, it will decrease the compressive strength. And also a lot of efflorescence will happen in the concrete. So we have to make sure that these things are taken care of. If these things are taken care, and it can be good for mass concreting or we can make the plain cement concrete. But if you are making the reinforced cement concrete, then it will not be a better option because we have the steel there. So reinforced cement concrete, definitely the strength will be compromised. But in the case of plain cement concrete, in mass purposes, we can use it like for any uh, normal non-load bearing walls. Because in the case of load bearing walls, it will definitely be a problem. But in the case of non-load bearing walls, we can use this kind of water. Okay, so there is another views. Okay, so the next question says that possible risk of using reclaimed water for agriculture and aquaculture purposes could be reduced salinity of soil and water, bioaccumulation of toxic chemicals, reduced sodium absorption ratio in the soil, all of the above. So what can be a possible risk of using reclaimed water for agriculture and aquaculture purposes?
So mainly bioaccumulation of toxic chemicals. This is a very much problem for the aquaculture and all these things.
Exactly. So option B is the correct answer
Yes.
because because uh, what reclaimed water will do, it will increase the salinity of the soil. Okay, and also it will increase the sodium absorption ratio of the soil. But it is not reduced. So both A and C are wrong. Whereas B, bioaccumulation of toxic chemicals will happen. So option B is correct. So here we can see, so for any kind of agricultural operation, the deposition of the surfactant will make the soil hydrophobic and water repellent. And also high amount of sodium that is present in the water will increase the sodium absorption ratio of the soil and making it unsuitable for agriculture. And also there are maybe presence of coliforms in the soil which may be getting transmitted to the harvested food crops. So these are all the possible risks of using the reclaimed water uh, in agricultural purposes. Okay. So next question, which of the following is an appropriate example of indirect reuse of reclaimed water? So which is an appropriate example of indirect reuse? We have domestic gardening, irrigation of cash crops, recharge of groundwater, toilet flushing.
Alert flashing.
Why toilet flushing is an indirect reuse? We are talking about indirect reuse, not direct reuse.
That is recharge of groundwater.
Exactly. So recharge of groundwater is an indirect reuse because toilet flushing is a direct reuse. We are maybe treating it or very minimal without treatment or very minimal treatment. We can directly use the reclaimed water. Okay, so it's an example of direct use. So if we even see the levels of treatment for various things, like after the primary treatment, there are no uses are recommended. Whereas after the secondary treatment, we can directly use in the case of surface irrigation of orchards or vineyards or non-food type crop irrigation or groundwater recharge of non-potable aquifer, not for potable aquifer, non-potable aquifers. Then there comes the tertiary treated water. So that can be used for toilet flushing, vehicle washing, food crop irrigation, and at last we have the indirect potable use, which are the groundwater recharge of potable aquifer and the surface water reservoir augmentation. So both of these are indirect potable use. Okay, we'll see the next question. Dash is a relatively safer mode of recycling untreated domestic wastewater within household premises. So bathing pets, kitchen gardening, floor washing, toilet flushing. So which of the following is a relatively safer method of using untreated domestic wastewater?
Alert flashing.
Toilet flushing. So toilet flushing is the most safest option for using the untreated wastewater. So it is the right option. So we have the all the reuse. treatments given here. Okay. So now the last question. Treated wastewater blended with water in a raw water reservoir of a water treatment facility is an appropriate example of direct potable reuse, indirect potable reuse, non-potable reuse, restricted impoundment. So here we are blending the treated wastewater with the water in a raw water reservoir.
Answer is D, restricted impoundment.
Why it is restricted impoundment?
Because for this treated water, that parameter for mixing with other source, there these parameters to be fulfilled. Because
Exactly. Suppose we have fulfilled the parameters also. Hello, I think I lost connection. Are you able to hear me now? Okay, just wait a minute. Okay, so we were discussing. Are you able to hear now? Hello, am I audible? Okay, so we were discussing like if we are blending the treated wastewater with a water in a raw water reservoir. So what is an example? What is the option for this? So it's the option of direct potable reuse because if we are making it fill the groundwater aquifer or any other surface water augmentation, then it is an indirect potable reuse. Whereas if we are achieving the treatment efficiency required for direct potable reuse and we are blending it with a raw water reservoir, then it is an example of direct potable reuse. Okay. So here also we can see the different types of direct usage and indirect usage. So the left hand side shows indirect potable reuse because after the advanced water treatment plant, it is going to the aquifer research or to the receiving surface water. Whereas in the right hand side, we can see that after the advanced water treatment plant, it is directly going to the like after water treatment plant. Okay, so there must be some reservoirs present to which the advanced treated water is going into. So this is the example of a direct potable reuse. Okay, so I hope it is clear. Okay, so these are all the questions which I had for today. Uh, it was mostly it was all theoretical. I didn't have any numerical for this week. And guys, do remember that next week I will have an extra session on probably on Wednesday. I will confirm it to you. So where we will solve only numericals based on all the chapters we have seen till now. So it will be a kind of refresher course. So it will be a 2 hour long session where I will solve all like majorly I will try to cover all the concepts that we have learned till now, and I will keep it as only numericals. So please do join. I think it will be on Wednesday from 5 to 7 p.m. Okay. Do you have any issues with this timing, or is it okay?
7 to 9 is good.
Actually, 7 to 9, that slot is, I think, not free that time. So I got only Wednesday 5 to 7. Will it be a very big problem for you?
For me, it is okay, sir. I don't know about others.
Okay. Saket, I will try to change if possible, but I don't think it will be possible.
I will try to manage.
Okay, so it will be on Wednesday. We will try to cover all the concepts that we have learned till now. But next Tuesday, there will be similar class for the last week, that is week 12 from 7 o'clock. But on Wednesday, I think most probably it will be from 5 to 7. Okay, so please try to, don't forget about the class. I will send you the reminder also and the link. Uh, do join that class also, and it will be totally numerical. Okay. So anything else about this week? Because it was pretty simple, I think. Do you have any doubts or concerns regarding the portions of this week? It was very direct, I think. You might not have faced much. Only the, and you don't have to remember all the different treatment efficiencies required and whatever the pH, BOD levels, COD levels. Just keep a basic idea. Just remember the ranges. Don't need No need to remember all the USEP or WHO guidelines. It is not that very much required, but you should know the different ranges of treatment efficiencies. Okay, like which is for what we need the most treated water, for which the least treated water is required. Just remember the ranges, so it will be better for you to make judgments in multiple choice questions. And I hope you all have registered for the certification exam, right? Have you all registered, or you are?
Me registered, sir.
Okay,
I am.
fine. Just try to give the exam and get the certification. It will be useful for you. So, do you have any other concerns for this week? And also, if you want any specific topic or specific type of question to be discussed on that Wednesday class, please send me an email, or you can tell me right now. So I will prepare my questions accordingly. Like whichever topic you found difficulty to solve questions, I will try to find questions from that, or else I will make my own questions. Okay. So if you have any suggestions for me that this chapter or this type of questions uh, we should practice, then please let me know uh, before Sunday or Monday, so that I can prepare accordingly. Is it fine? Okay, please make a note of it and let me know any particular session or any particular concept that I should discuss in detail. Not the numerical, but the conceptual thing. Maybe the process flow diagram, like how we discuss the activated sludge process. If you want me to discuss any similar kind of treatment technology, so we can discuss in that class. But please let me know it beforehand so that I can prepare it accordingly. Okay, so if you don't have any other, yeah, Abdul, you are saying something?
Okay, sir. Then, sir, for this, some problems connected with the population forecast method,
Okay,
arithmetical, that type of one or two question, please
fine,
included
fine,
that.
fine, fine.
Because
I
this
will.
is very, very common for the design criteria. Things these are very important. That one or two problems, please be
Sure,
involved.
sure. So I will keep a question in which we will do it by arithmetic, geometric, incremental increase,
Geometry.
and
Yeah.
logistic curve. We will do
Okay.
all four methods for a problem.
Okay.
That is okay.
Okay.
If you have any other queries also, or if you other suggestions for me, please write it to my mail ID. Okay, before Sunday preferably.
Okay, sir.
Okay. Okay, so if you don't have any more issues, we can leave the session. We will meet again next week, 17th October at 7 o'clock.
Sir,
Ah,
some problems regarding design of grid chamber
grid chamber.
and,
Okay.
sir, and particle velocity,
1 minute, just 2 minutes. I will make a note of it.
this type of problems.
Okay, so you are saying, uh, just tell me once again, grid chamber.
Grid chamber
Okay.
means design of grid chamber and
Ah,
settling velocity
set,
related to settling velocity
settling velocity. Okay, fine.
and removal efficiency.
Okay, settling. Uh, do you want to solve that graphical problem of related to settling velocity, or I think it is not required because there are some graphical problems also on type 1 and type 2 settling. Uh, I don't think it's required at this level. Maybe in the master's or PhD level it is required. Okay, I'll see to it. And Abdul told about this population forecasting. Okay.
So I will send you a sample problem.
Okay, fine. If it is there, it is okay. Just send it to me. I will
Okay, sir.
try to get simple problems.
Okay, sir.
Okay, okay, guys. You can leave the session now. We will meet again next week. Thank you. Thank you so much.
The settling model and settling velocity distribution
Settling model and settling velocity. Okay. Settling model
and settling velocity distribution.
and settling velocity distribution. Okay, okay, fine, fine.
The most probable number.
MPN. Okay, fine. MPN. We can discuss
Yeah,
that.
sir. Yeah. This is also important
Yeah,
topic.
I think I gave you one homework question like this for MPN.
Yes, sir, but still something is not clear to me. I will discuss with you in mail. It's
Fine,
better
fine,
to.
fine, fine. If you have any particular problem which you are not able to understand, you can send it to your mail. Okay,
Yes, sir.
we will discuss that. MPN. Anything else?
Okay, thank you, sir.
Okay, thank you. Thank
Okay, sir. Thank you, sir.
you. Okay, thank you. Thank you so much.